Is it recording the screen?
Yeah, I'll just put in whatever other video.
Okay.
If you want to just put the voice on.
There were three main important design decisions that we used for the project. The first was a retractable arm. We use this because it fits the size constraints and allows us to score closer to the goal. We also decided to have a funnel ball collecting mechanism. This was done so that when we received balls, they would fall into a funnel and not fall out of the holder. The last design decision that we used was line following. We found out that the motors were erratic, so constant adjustments were always necessary. Using line following, we could make adjustments as we go instead of hoping to go in the right direction.
The construction for our robot began in SolidWorks, where several parts came to life to reflect the design we had agreed upon as a group. The main component of the design is a holster for the tape measure, which combined several key features into one part. This part would allow us to adjust the angle of the tape extension as needed without having to adjust any other parts, as all components that interfaced with the tape measure would be mounted directly to the holster. Other modeled parts include custom stepper mounts, a stand for the IR board, a scoring cup, a battery holster, and 2 silos for electronics. All of these parts were 3D printed and modified throughout the process of optimizing our design.
Our code included a variety of functions to facilitate navigation and shooting the ball. Go.H included some of the most important functions for navigation and for scoring. We used enumerated variables to point ourselves in the right directions. Our Go function made it easy to choose between forward, reverse, clockwise, counterclockwise, or a number of other options. We also included this turn to function, which allowed us to turn to any angle that we wanted. Finally, our shoot function shot the arm out using a ramping function. As the arm returned, we used our ball color sensing QRD to make the arm return to the right position every time. Finally, we had a number of other functions that allowed us to follow lines and find lines, detect the infrared, delay, center over the cross, and track the amount of time elapsed. Many of these functions were deprecated as our priorities changed or as we moved the position of the QRD sensors.
We learned from our original robot design that DC motors and servos were too unreliable for us to score consistently. We decided to overhaul and focus on more productive design choices. We also learned that relying solely on inertia was unreliable with our current ramping function and ball holder. We should change the ball holder to launch the ball better or improve the ramping function to make it more reliable. We should spend more time refining the QRDs to line follow and place them closer together. We would use our IR sensor to find which goal we should shoot towards, and finally, we would refine our step counting function so that we could turn to whatever angle was needed.
This is going to be a lot of cutting.